Hi folks, welcome back to another episode of Teardown Tuesday. Today we're taking a look at an interesting little device. It's a type of switch that's commonly used in gas burner systems that have some kind of blower or draft inducer. And this particular switch is designed to detect suction or pull on a part of the gas burner system. So if the combustion blower is running and we get a little bit of suction or a little bit of pull in one of the fittings or pipes, this switch just confirms that that combustion blower is running. If we take a look at it here, the label on this has a couple of part numbers and it has this rating. And the rating for this is very small. You can see it's 0.26 water column. So it takes almost no suction force at all to actuate. The other thing that's noticeable on this data plate or this label is the mount vertically. And that means that in its installation, in its correct installation, it needs to be mounted like this. So if you have a flat panel, mounting the diaphragm vertically is like this. So it's pretty straightforward as far as its construction. From the outside we can tell there's a very small micro switch and there's a fitting and then there's a mounting bracket. And the fitting would take a piece of tubing or hose that would connect back into our burner system. I've got a little hand pump here, a vacuum hand pump, and if we connect that up, you'll be able to both see and hear just how small that 0.26 inch water column really is. And you'll hear this click really before the needle even moves. So I'm just barely squeezing this. So it takes almost no suction pressure at all to get that diaphragm to pull that switch. Now the other thing I've got here is I've got my multimeter and it's set on continuity. You can hear it ring out. If we connect the leads of our meter onto this micro switch and then apply that same very small suction pressure, again, it takes almost no vacuum at all to close that switch, complete that circuit. So there's not much else on the exterior of this. So let's go ahead and take it apart and see what's inside. Alright, so I've got a small cut started here and we're just going to work this all the way around until the entire casing pops apart. And there it is, the inside of our diaphragm switch. You can see it's very simple. There's a small spring and the spring is up against a threaded adjuster. You can see the threads down in there, and they had put a sealant or a lock on the outside so that once it was set at the factory we could not field adjust it. And then the diaphragm itself is just this thin rubber material and a little plunger, and that little plunger comes back up and presses our micro switch. So in this case, if our micro switch was open when that plunger was pushed up against it and the vacuum pressure pulled the pressure off to release it to a closed position, that would tell us we were dealing with a normally closed micro switch that opens when we push it. So let's double check that here. So if it's normally closed, we should ring out. Yeah, so you can hear the switch has continuity, so it's normally closed, and then when the action happens on the plunger, it opens. So it's considered a normally closed switch. When we talk about how something like this works, as far as what principles we're using, it uses a lot of the same principles we see in gas valves, where we have pressure over an area. So we have a given amount of surface area, a given amount of pressure across it, and the larger that area is, the more that small pressure is amplified. The switch itself, pretty basic, normally closed, spring return. When we talk about how something like this would fail, the failures are going to almost always be caused by an external factor. So if we were to get any kind of oil or water down inside here, that could disrupt or jam or cause this diaphragm to harden. Outside of that, an electrical fault that pulled too much current through our switch could also cause this to fail. But these are very simple. You see, there's only this one moving part. There's not much in here to go wrong. It is interesting though to take a look at how they have molded this. We have a negative side with our attachment for our hose there, and we have a positive side. And if we were to have the hose attached on this side, we'd have the same basic mechanism, but it would take positive pressure to cause that diaphragm to move instead of negative. So I'm sure there are other versions of this that have additional fittings molded in. Be very easy for them to add that in manufacturing. But that's it. That's a basic diaphragm pressure switch. All right, that'll do it for now. Thanks for watching.